Okay, so let's take a look at how we would graph systems of inequalities. And before we do that, we're just going to start by graphing a basic linear inequality and a basic quadratic inequality, just to remember the symbols that go along with it and the shading and all the things that we do to go along with it as well. We will use our calculator to do a lot of this, but I think for right now, just doing the basic stuff, we're just going to graph it and shade it by hand. So a couple of things to remember. First of all, our inequality symbols that we should all remember and know is that we have less than and greater than or equal to. So we have less than or equal to and greater than or equal to. And if we are going to graph those on a coordinate plane, we are going to use a solid line on the graph. So it would be a solid line when we go to graph it. If it is less than or greater than with no line underneath of that, it just says less than or greater than, then that means that we would use a dashed line. So when we graph it, we would use a dashed line to show that. We will eventually, I will show you how to use your calculator to do a lot of this, but let's just do some basic practice with solid line, dashed line, shading above, below, that kind of a thing. So starting out, we're going to do a vertical line and a horizontal line, just to remind us of what those two things actually look like in an equation or an inequality and a graph. So our first one here is y is greater than or equal to 3. Y is greater than or equal to 3 is a horizontal line, okay, at 3. Okay, so we have 3, and since it's or equal to, that horizontal line is going to be a solid line. So we're going to draw a solid line, like so. And then we need to figure out if we are going to shade it, or not if we're going to shade it, but where we're going to shade it. And it is greater than or equal to. And one way that we can check to see which place we actually shade is we can do a test point. And our easiest test point is, let's test, 0, 0. Okay, if 0, 0 makes the inequality true, then we shade that part of the graph. If it does not, then we shade the opposite part. So we would have, if we had 0, 0, well, that would mean y is 0, and we would ask ourselves, is 0 greater than or equal to 3? Well, the answer to that is no, it is not. And so we would not shade where 0, 0 is. We would shade on the opposite part. So we would shade above, which is also logical because greater than or equal to, greater than would be above, less than would be below. The second one is a vertical line. It only has an x in it, and it's at -2, and it is less than, or excuse me, not less than, but it is greater than, so x is greater than -2. So since there is no or equal to, we are going to make it a dashed line at -2. Okay, and then we have to decide, are we going to shade to the left or are we going to shade to the right? If it is greater than, logically speaking, we would shade to the right because to the right is bigger, would be greater than. So we would shade there. If we are not sure where to shade, two things we can do. One, I will show you eventually how to look on your calculator and it'll show you where to shade. Or two, we just do that test point where we use 0, 0. And if we use 0, 0, that would mean x is 0 and 0 is greater than -2. So this ordered pair 0, 0 is in the shaded region, so we know we've shaded the right area. And then down here, we just have another one. We have a less than or equal to, so we know it's going to be a solid line. And we are just going to start by graphing that line. So our y-intercept is 1. We're going to start at 1. And our slope is 2 over 1. So we're going to rise 2, run 1, rise 2, run 1, rise 2, run 1, and so on. Go down 2, back 1, down 2, back 1. And since it is an or equal to, we are going to make that a solid line. Okay, and then we can do a test point. Okay, and again, 0, 0 is here. It's on kind of on the lower right hand side. And if we test the point 0, 0, and it makes it true, then we shade that right hand side. If it makes it untrue, then we would shade the other side. Also thinking less than or equal to, thinking above or below. where 0, 0 is below the line. As you look at the slope of it, it is below. So in my mind, theoretically, we would shade where the 0, 0 is labeled at, but let's just double check. So if we use the ordered pair to check 0, 0, we'd have 0 is less than equal to 2 times 0 plus 1. 0 is less than or equal to 1. That is true. Since it is true, that means that we would shade where 0, 0 is, which is here. And when we shade like the entire section, because when we do systems of inequalities here in a little while, like tomorrow and stuff, we're going to have everything shaded so we can see where they actually overlap. So, and then just a couple of other things here with inequalities. We want to keep the y on the left. So I'm going to write my work over here. So I have my inequality is x minus y is less than 2. In order to graph it, we need to get y by itself. And we don't want to add y to both sides because with that inequality, it's easier to graph when the y is on the left. So also allow us to remember another rule about inequalities. So I'm going to subtract x from both sides, and I have negative y is less than negative x plus 2. Well, I don't want negative y, I want positive y. So I'm going to divide everything by negative 1. And when we do that, one of the rules with inequalities is that you switch the symbol when dividing by a negative. So we would have y, we are going to switch the symbol from less than to greater than. And we would have negative x divided by negative 1 would be positive x minus 2. So we're going to graph that. We'd start at negative 2, and our slope would be 1 over 1. Okay, and then it is a less than. There is no or equal to, so we're going to have a dashed line. And it is greater than. If we're thinking above or below, greater than would be above, and less than would be below, and this is the part that is above, so we would shade all of that in, and we can test the point 0, 0. As long as it doesn't go, your line doesn't go through 0, 0, you can use the point 0, 0 as your test point, because that's usually the easiest one to do, okay? So if we tested 0, 0, okay, in this inequality, we would have 0 is greater than 0 minus 2. And in fact, this point, this ordered pair, 0, 0, is in the shaded region, so that's good. Okay, so that's just remembering how to graph and shade and everything a linear inequality. And the next thing that we are going to look at is sketching and graphing a quadratic inequality. Okay, so here we have quadratic inequalities. These are going to be parabolas. The first two are in standard form, and then the second two are in vertex form. Okay, and for the first part, again, of this lesson with inequalities and things like that, we are not going to use our graphing calculator just yet. And you guys probably are aware that using a Desmos graphing calculator makes this way easier. But we can also use our scientific calculators, but we'll get into that when we do systems a little bit later. So for right now, we are just going to sketch a parabola, and we are going to just graph it, just focusing on solid versus dashed line, and then shading on the inside or the outside of the parabola. So if we have y is greater than or equal to x squared minus 1, that is basically just your parent function parabola opening up, and it is just shifted down 1 unit, okay? So, and as far as when we graph them for right now, they're going to be very basic like this. We're going to have the basic parabola, and we are just going to shift everything down, okay? So if we had our original one, would be at 0, 0, we take and we move everything down. So we'd be here, and then we would have a couple of other ordered pairs here that we could, and it is an or equal to, so we are going to make it solid line. Okay, and I am not worried too much about those exact ordered pairs. It should be obvious that it is shifted down 1 here. Okay, and again, we can talk more about how to find all of these ordered pairs with our calculators later, but we have y is greater than or equal to. Greater than or equal to would be above, okay? Above in this case would be here, above the line. So if we were thinking about it, everything on the outside would be below. And if we're not sure, we can always just test that point 0, 0, where we'd say 0 is greater than or equal to 0 squared minus 1. 0 is greater than negative 1, so 0, 0 is inside. We would shade the inside. Okay, let's do this next one here, where we've got, it's just a parabola, and it is shifted up 3 units. So we do 1, 2, 3, and we would have a dashed line. So we're just going to do a basic sketch of that parabola for right now. Oopsie daisies. It's not the best dashed line I've ever done, but it is less than, so it's going to be dashed. And then we would have, if we tested the ordered pair 0, 0 right here, 0 is less than 0 squared plus 3 is 3. And yes, that would be the area that would be shaded, is where the 0, 0 is, which is on the outside. Also thinking less than would be below. So if we think about above would be on the inside, below would be on the outside. And these two here, the last two, are in vertex form. Okay, so we're going to have to remember how to find our vertex. So our vertex here is at H, K. So our vertex is at -1, -3. So we're going to find our vertex, and we're just going to sketch our graph. -1, -3, and it is a or equal to, so we are going to sketch our parabola like so. I'm just going to sketch it real quick, not worrying terribly about the exact ordered pairs other than our vertex. And we just have to decide, are we going to shade on the inside or the outside? And less than or equal to is going to be on the outside. That is below, if you think about where that vertex is, that is below the vertex and everything on the outside. We could also test the ordered pair 0, 0. If we tested 0, 0, we would have 0 is less than or equal to 0 minus 1 is -1. -1 squared is 1. 1 minus 3 is -2. And 0 is not less than or equal to -2. So we would shade on the outside. And then our last little parabola here, we have our negative out in front, so we know it's going to be a frowny face, and our H and our K. So our vertex is going to be at 2, -1. So we're going to be at 2, -1, and it is going to open down like so. And it is going to be a dashed line. So I'm going to go ahead and make it into a dashed line. I didn't notice that. I forgot when I was making my first one there. And then we're going to figure out if we are going to shade on the inside of the parabola or the outside. It is a greater than. Again, greater than. If we look at the vertex, anything that is above it would be greater. So I'm going to say that we are going to shade greater than. And when we shade greater than, we shade everything all the way around it. If it was less than, it would have been below it, which would have been inside of that parabola. And we could also, again, do a test point where we would say 0 is greater than -0 minus 2 squared minus 1. 0 minus 2 is -2. -2 squared is 4. We have that negative out in front, which would be -4 minus 1. And 0 is, in fact, greater than -5. So yes, this point at 0, 0 is part of the solution, so we would go ahead and shade it. Okay, so we've got all of these different examples of how to shade. These are just like one linear or quadratic inequality. Okay, before we go any further, I want you to go back into Schoology, and I would like for you to watch, there is a 3-minute video that explains how to use your calculator, to graph an inequality. okay? And it shows how to to put it into the right application, how to change the greater than, less than, or equal to. It's a whole lot easier to watch that than to have me try to explain the steps on how to do it. And so I want you to pause the video, watch that, and so then when I start talking about what it's going to do on your calculator, you'll know exactly what I'm talking about. So hopefully you paused the video and went back and watched, because I'm not going to go back and explain how to use the calculator again. The short video explained it pretty darn well. So we are just going to graph on our graphing calculator. You need to go into your y equals, change the inequality for these first two inequalities that we have here. Okay, so we have y is greater than x plus 3, y is less than negative x minus 1. And we can just graph those pretty easily. 1, 2, 3, and then we go up 1 over 1 like this, down 1, back 1, and it's just a dashed line. If you put that into your graphing calculator, it will graph it for you, and being that it is greater than, it would shade this part up here for you. It would show you that that part is shaded. And then if you went into your second y equals, you're going to put both of these in at the same time. You would get, you'd change that inequality here. You'd go arrow over and change the inequality and stuff, and you would go down. We're going to graph it. Let me do a different color. We're going to graph, and we're going to go ahead like so, and it's going to again be a dashed line like that, and it is less than, and it will shade then below, oops, daisies, it will shade below, red, I'll get there, it'll shade below there like that, and you will see that they overlap. There's going to be some of the blue lines and some of the red lines, I think, so the colors that your calculator is going to use. And what we are looking for is to know exactly the overlapping part that is shaded. So what we're looking at is the solid and dashed lines. Are they in the right location? And is it clearly shaded darker where the solution is? And then the only other thing that you need to do is figure out where those lines intersect. And in this case, they intersect at -2, 1. And it should be easy to figure that out by looking at it. But if not, remember that there is the tool where you can calculate an intersection, where you can go second, calculate, and you can calculate an intersection using bounds, left bound, right bound kind of a thing. Left curve, right curve, I think is what they might use. So it's really not too tough, and your calculator can help you quite a bit. But again, it's only helpful if you know how to use your calculator, and that short video that you're supposed to have watched shows you how to actually change your mode so that you can actually be in an inequality place. Okay, so we've got y is less than -x plus 3. Again, you can put that into your calculator. You just change the inequality to less than. The second line, you would change the inequality to greater than, and you would graph the lines. So you'd have -x plus 3. So we'd be negative, down 1, back 1, down 1, back 1, like so, up 1 over 1, and it's a less than, so we're going to have a dashed line. And it is less than. Less than means that we are going to shade below here like that. We're going to shade everything below like that. And then we have in blue, we have y is greater than -1/2 x plus 2. So I'm going to start at 2. That's just, those two are not on the same place. -1/2 means down 1, back 2, down 1, back 2, down 1, back 2, or up 1 over 2, up 1 over 2. And again, it's a dashed line. Okay, so a dashed line, like so. And it is greater than. Greater than means above, so I would be shading, oops, I wanted blue, everything above that line, up here like this. And if you notice, we have two dashed lines that are graphed correctly. We have this is the definite overlap, and the ordered pair where they cross is at 2, 1. Okay, so again, use your calculator to help you, or if you don't need your calculator, you can, these are pretty easy to sketch graphs of, so you don't have to. And then last but not least, we got a quadratic and a line. So we're going to have a parabola with a line going through it. And then the last one has 3. You can do as many different graphs as you need, different inequalities on there. So we have x squared, y is greater than or equal to x squared minus 1. So we're going to be down 1. Okay, and we are sketching the graph. Okay, like so. So this is, we are actually probably going to need, for our intersection points, we probably will need that intersection tool, so we can remember how to do that. And so if I have greater than or equal to solid line, that would be inside of the, let's see, that's in blue. So we're going to be greater than is going to be on the inside. Okay, like that. And then we have a line as well. Okay, x plus 1, so we're going to start at 1, and we are going to go up 1 over 1, up 1 over 1, down 1, back 1, down 1, back 1, that kind of like that. And then we have a line, and it is, oops, I kind of missed my mark there just a little bit, less than or equal to. Less than means that we are going to be below. All of this is going to be everything below. And then the part that overlaps should be easy to see. The part that overlaps is this part in here, okay? And the 2 places where they intersect, you can either tell by looking, are going to be at -1, 0, and at 2, 3. And again, my parabola wasn't graphed exactly right. But if you need to, like, you can always go into second trace, which will bring up a menu, and you're going to go to number 5, which is intersect. Okay, and it will ask you for a left curve, right curve, so you'll have to do it twice, but it can give you both of those ordered pairs. The other option is you can go to your table of values and see where they are both the same number, if you want to do it that way, but you do have to be able to figure out where those lines actually intersect. And then the last one here, very last thing, I would like for you to go ahead and try this one. I want you to pause the video, put all 3 of them into the graphing calculator, and I want you to label, I want you to pay attention to solid versus dashed. I want you to pay attention to where your okay, so if you did this correctly, you should have a graph that looks like this. The kind of yellowish part in the middle is where all 3 of them overlap. They are all 3 solid lines, and they all have everything shaded with the ordered pairs where they intersect are clearly labeled. So is 2 homework assignments. One is they're both in Schoology. One is called graphing linear and quadratic. Inequalities. Okay, so that's one. And then the second assignment is a separate page, and it's called 7.5 day 2 homework with systems of inequalities. So there are 2 separate worksheets that need to be finished and completed. And you will have time tomorrow to finish those and work on them if need be. So get done with what you can get done today, and you can have some time tomorrow as well.